Here we kind of work in reverse. I'm going to give you some information about a hyperbola, and we're going to try to figure out the equation of a hyperbola. And the first thing you need to understand is, what does the equation of a hyperbola look like? Well, it looks like a squared fraction minus another squared fraction equals 1. Okay? And if you're not familiar with that, you may want to go watch a different video where this equation is introduced. But let's get started. So I'm going to be using a graph to plot this information and do some side work, hopefully to help me determine all the pieces of the equation that we need to find. Okay, so let's put a graph in there. And let's plot what is given to us here in black. So I've got a vertex at 1, 0, and another one at negative 1, 0. So a vertex and a vertex. And I know that hyperbolas are symmetric, so I can get lots of information immediately from this. For one, I can tell that the center is exactly between those. So my center is at the order pair 0, 0, which means in my equation I will have, like if this were 2, I would have x minus 2 squared. Or if this were negative 3, I'd have x plus 3 squared. Since it's 0, it's just x squared. Or without the parentheses, x squared. And similarly, I've got y minus 0 or y plus 0, whichever way you want to look at it, so I get a y squared in my equation. So I know that those two pieces are going to be my numerators in my equation. Okay? Now, this hyperbola is a horizontal hyperbola. Meaning, because my vertices are left and right, my curve is going to open left and right. That tells me that my x fraction is positive, is the positive one. X meaning horizontal. So I know this is my positive fraction and this is my negative fraction. So at this point I've got x squared, positive x squared over something, minus y squared over something equals 1. Now I just need to figure out what my denominators are. Well, I know even more. I know that from my center to my vertex, this distance right here, that's my a value. So I know that a is 1. My horizontal distance is 1. Okay? Since this is horizontal, it goes under the x fraction. Now, the tricky part about this is what everybody forgets, is that you have to square it before you put it into the equation. Everything in this equation is squared. So a squared is also 1, because 1 squared is 1. So now I have x squared over 1 minus y squared over some unknown equals 1. All of that just from my vertices. We're 3/4 of the way done. I just have to figure out my last denominator. Okay? Now, so I've taken care of these guys. Now I need to plot this focus at negative 2, 0. So here's a focus. Which means I also have a focus the other direction at symmetric at 2, 0. And what that helps me with is the distance from the center to a focus is my C value. So I know now that C is 2. Now C is not what goes here. Okay? I have to use A and B for my denominators. But since I know A and I know C, I can find B. Because I know that C squared equals A squared plus B squared for a hyperbola. So C squared is 2 squared equals A squared, which is 1 squared, plus B squared. Now I can solve for B. So I have 4 equals 1 plus B squared, subtract 1, so B squared equals 3, which means B is the square root of 3. So now that's going to be my vertical distance here. This, of course, equals 1 point something as a number, as a decimal number. So if I were to plot that, I'd go 1 point something up and 1 point something down. I could draw my center rectangle now right here. I could draw my asymptotes and my curve and be done with the graph. However, I'm not asked for the curve or the graph, I'm asked for the equation, which is what we're working on right here. Okay, so now I just need this denominator. Notice that b was measured up and down. That means it goes under the y fraction, because y is the up and down measurement in a graph. But again, before I put this number into my equation, I have to square it. So if I square both sides, I get b squared equals 3. And we already knew that b squared equals 3. I need the squared version in my equation. So I end up with x squared over 1 minus y squared over 3 equals 1. And that is my equation for that hyperbola. Or dividing anything by 1, like 5 divided by 1 is just 5. X squared divided by 1 is just x squared. So you could simplify it a bit to write x squared only minus y squared over 3 equals 1. Either one of those would be appropriate. So this was a good example of looking at the equation in a reverse fashion. You use the center to get your numerators, and you use your a and b values to get your denominators.